vectors. You'll see a lot of these, I don't know if this one does it or not, you'll see a lot of these textbooks when they talk about vectors want to get you into angles and sines and cosines and tangents, and I'm here to tell you that in practice and for the test, I would say not do any of that. You'll get yourself so flipped around when you start talking about, well, is it the cosine of that or the sine of that? What we want to do is take everything angle-based. If they give you an angles, take them right into the length of the lines, the lengths of the triangles. Just get angles out of it as soon as you can. If they give you angles, you're stuck with it. You got to use it. But just get rid of it as quickly as you can. So when we talk about vectors, really what are we talking about? Vectors are just loads in a direction. So I could have my ubiquitous 1,000 pounds here. Along the very same line, I could have another load of 1,000 pounds. That's essentially equal to one line that's twice as long that equals, it's equal to 2,000 pounds. Those are essentially equal to one another. Conversely, I could have a load coming down that's 300 pounds. And along this same line, have another load coming up that's 100 pounds. That's equal to one that comes down, 200 pounds. Think of the loads just like you would a length of line. A line that's not 300 pounds, but is 300 inches or 300 units or 300 feet or centimeters or whatever you want. So those are essentially equal to each other. The other one that we're really going to get into is if you've got a load that comes up, £300, and you've got another load that goes that way, that's 400 pounds, that is equal to a load that comes up at a diagonal that is 500 pounds. Now, why in the world would that make sense? Well, you've got a line that's 400 units or inches or feet or whatever you want. The other one that's 300 up. This 500 is essentially one that's 400 over and 300 up. So when we start talking about trusses here in a minute, this is going to be very important because you can go both ways with this. You can take any couple loads and make it into an angle load. But more importantly, with trusses, you've got all these angled members everywhere. And that's going to drive us crazy when we start talking about, well, what's up is equal to what's down, what's left is equal to what's right. So more often we're going to be taking this, putting it into these terms, these up and down and left and right terms, so we can analyze them, we can run them through our engine, through our statics engine, and then they'll say, well, what's the load in that diagonal? Well, then you're going to have to take that and transfer it back into an angle load. So we're going to be given this, and we're going to be asked for this. But we're going to have to transfer it into these terms, into an up, down, and a left, right term. And then at the end of the problem, we're going to have to go back and do something with it there. Another way of thinking about this, and I'm really going to butcher a drawing right now. Let's see if you can identify what I'm drawing right now. The United States of America. Yeah, good. So here we are at CMH, right? Columbus. And I want to fly down here to Austin to see my brother. Now the pilot says that's either 500 miles. By the way, I'm using 3, 4, 5 triangles for pretty much all my examples to make it easy. 3, 4, 5 triangles to make it all easy. He says, well, I can't fly direct. We got to have a layover. I can either fly 400 miles down to Atlanta and then 300 miles over to Austin, I can either do that, or we're going to fly 300 miles over to wherever you want, Minneapolis, and then 400 miles down south. That's really all we're doing. We're just taking a diagonal and breaking it out into horizontal and verticals, or vice versa. We're taking a horizontal and vertical and transferring it into two. So I said we're going to use ratios for as much as we can. Let's say I've got a diagonal member like this, and I'm given that it's 4 feet long that way, and I'm given that it is 3 feet long that way. It has a compressive load in it of 500 pounds. All right, so first of all, how long is this thing from here to here? How do we figure that out? 5 feet? And how do we figure that out? 3 squared plus 4 squared is equal to 25. Square root of that is equal to, that's why I'm using 3, 4, 5 triangle. If it were, let's say it is 5 feet and 5 feet, it's 5 squared plus 5 squared, the square root of that. Right? Another way you can, when you get 45s like that, another thing you can do is, if it was 1 and 1, it'd be the square root of 2. That's equal to 1.4 something. So you can take whatever length it is. Let's say it's 4 feet and 4 feet. 4 feet times square root of 2 is going to be equal to this length, if it's a 45 degree. Now, if they don't give you these in the problem, like I said, we're going to have to figure it out based off of it. If they give you 30 degrees or whatever it is, the very first thing I suggest you do is get rid of this and replace it with that and that. So do that, Sakatoa? You hear that? Opposite over adjacent, you remember all that stuff. That's the first thing you would do, is to get it into that. So I got 500 pounds coming into this member that's 5 feet long. And what I want to do is break it out into its two components. So I want to get rid of this 500 pounds, essentially. And I want to break it into a load that goes this way, and a load that goes that way. And I want to break this thing into a load that goes that way, and a load that goes that way. What are these now? Well, let's take this vertical one first. What does that equal to? The little formula we're going to give is what you want. Well, I'm sorry. This is going to equal to the load that you got, which is 500 pounds, times what you want over what you got. So what do I mean by that? So the load I've got is 500 pounds. What I want is the vertical component of that, which is equivalent to this 3 feet. So I want it in the 3 foot direction. What do I got? Well, I got a 5 foot direction. And so that's equal to 500 times 3 divided by 5, 300 pounds. So how about in the other direction? I want to figure out what this guy is now. Well, again, all I've got is 500 pounds. Now, what do I want? There's my little formula right there. Well, I want the 4 foot direction. I want that direction. So 4 foot divided by what I got, 5 foot, equal to 400 pounds. Now, what if I did this the other way around? I said, well, I've got this vertical and I want the horizontal. So I've got a 300 pound load. The direction I want is the 4-foot direction. The direction I got is the 3-foot direction. 300 times 4/3 is equal to 400. They're the same number. You can do the same thing by taking these loads and saying, well, 300 times what I want, which is 5, divided by what I got, which is the 3-foot direction, is equal to 500 pounds. You can go about that in a number of different ways.